It's a near-future scenario that might happen. The first humans on Mars are hundreds of miles off course, stranded deep in the gigantic Valles Marineris. They can't communicate with Earth, and their damaged habitat module is leaking air. Almost every Mars movie imagines a breathable atmosphere in at least one section of Mars so the actors can take off their helmets. But in fact, Mars' atmosphere is 95% carbon dioxide and as thin as Earth's atmosphere at 100,000 feet.
I'm often surprised by how caught up we can be by sort of this romantic vision of Mars. It looks like Utah or California here. But the truth is it's a lethal place.
The astronauts have one chance, and they take it. They assemble the rover, which has a 3-week air supply.
A pressurized rover is sort of your RV. You are living inside the rover. It's pressurized. You're in shirt sleeves. You don't have to be wearing a spacesuit while you're driving it or living or working inside.
The rover is functional, and so is its communication system. The astronauts radio home that they're alive.
If some component or something goes wrong on it, there's a backup that wouldn't lose the mission. So redundancy can be a very good thing, or at least the ability to design for a failure, if you will.
But the conversations are not like the constant back and forth of the Apollo moon missions.
Imagine this ball represents a message, a conversation between an astronaut on the moon, me, and Mission Control in Houston, Texas. Now, I'm standing a few inches away from Houston, but in reality, the moon is 240,000 miles away. Now, radio waves travel at the speed of light, 186,000 miles per second. So it's only about 3 seconds between "how are you" and "I'm fine." Pretty easy to hold a conversation. But Mars is, at minimum, about 150 times farther away than the moon. So I have to go all the way over to here. We can still communicate, but there's a longer delay. In reality, the distance between Earth and Mars is between 35 million and 240 million miles. So the time lag between "how are you" and "I'm fine" can be between about 6 and 44 minutes. That's for a complete exchange. So if there's an emergency, it can't be dealt with in real time. But there's a bigger problem. Like visible light, radio waves travel only in a straight line. And both Earth and Mars rotate on their axes. So there are times when people on the two planets can't communicate with each other. We can solve this with 2 properly positioned satellites. If there's a satellite orbiting Mars, a message can be sent from Mars to Mission Control in Houston. It gets sent to the satellite orbiting Mars, then to the Earth orbiting satellite, then to Mission Control, and back again. Now, there's still a time delay of up to 44 minutes between question and answer, but at least the Mars astronaut and Mission Control can formulate a survival plan.
Working through the communication lag, the plan takes shape. Load the fuel cell-powered rover with food and equipment and drive it east to where the Valles Marineris empties into an outflow valley, probably carved out billions of years ago when Mars had a thicker atmosphere and liquid water still flowed on its surface. From this exit point, it's less than a day's drive to the Earth return vehicle at the original landing site.
So you can imagine having a desperate trip across the Martian landscape to get back to the return vehicle and perhaps do a little bit of scientific research, but most importantly, save yourself and get back to Earth.